And I know you guys don't like these, but most likely when you get a diploma question, they're going to want to give you all this reading. Yeah, there's this stuff this is yeah how we actually figure out earthquake numbers, earthquakes. No, but they might give you a bunch, and then you have to pick which ones you need. So let's read through this. When you get to the diploma, please do not rush through your reading. Grab a highlighter, relax, maybe bring a little tea with you. Sit down and read through it. Oh, you can bring a thermos. Yeah. Okay. There's clear thermoses. They're see-through. I'm not sure. Okay, so the Richter scale, named after the American seismologist Charles Richter, is used to measure the magnitude of an earthquake. So you've seen this before, right? The magnitude of an earthquake is a measure of the amount of energy released. It is determined from the logarithm of the amplitude of the waves recorded by seismographs. So those machines that they use. The Richter scale is logarithmic. A difference in 1 unit magnitude corresponds to a factor of 10 difference in intensity. So 10 times more intense. This means that each whole number step represents a 10-fold increase. Therefore, a magnitude of 9 is 10 times larger than 8 and 100 times larger than a 7. What's going on? A magnitude of 1 on the Richter scale is equivalent to a large blast of construction site using approximately 14 kilograms of TNT. It is 10 times as intense as the 0 reference point. An earthquake with a magnitude of 10 to the 2 is of a 2 is 10 to the 2 times as intense as the 0 reference point, and so forth. So let's try a couple here. An earthquake of 8 is how many times more intense as an earthquake with a magnitude of 7? 10. Okay, how about 10. What's 7 compared to the 3? 10 to the 4, or 10 with 4 zeros, or 1 with 4 zeros, so 10,000 times as intense. How about a 4 compared to a 6? So notice how we did 10 to the 7 minus 3. Here would be, how about we're comparing a 4 to a 6? Is it more intense or less intense? Less. So what would it be? 10 to the negative 2, or what is 10 to the negative 2? 0.01, or 1/100th. Yeah.
0.01 times more intense?
Or 1/100th.
Yeah,
so 1/100th. It's when it's 1/100th or 0.01 times as tense, it's actually less intense. Anything less than 1 would be less intense. An earthquake of magnitude 4.8 to a 6.8, what would that be? No. Again, same as before, 10 to the negative 2, right? Because 4.8 is not as intense as 6.8. How about the Chile? What was the earthquake in Chile? It's at 9.5. It's insane. And what is the one in Italy in 1976? 6.5. Okay, and we're also and what is the one in Colombia? 5.9. 5. Thank you. Okay, so Chile compared to Italy, how many times more intense was it? How would we figure it out? 9.5 minus 6.5, which is 10 to the 3, or 1,000 times more intense than Italy's. And what's Italy's compared to Colombia? Oh wait, let's read this. Chile to Colombia. Sorry. Chile to Colombia would be 10 to the power of 4. 9.5 minus 5.5, or 10 to the 4, 10,000 times. An earthquake on Turkey is 6.9. And what's the one for Japan? 1933. 8.9? 1933 is 8.9? Okay, so what will that be? What's 6.9 minus 8.9? -2, so 10 to the -2, or 1/100th, or 0.01. So those earthquakes are not so bad, but it depends on how they word the question. So everything is built around this formula. We've seen how to compare the intensities of earthquakes. And so if we let M1 to be the first magnitude and M2 be the second magnitude. So the magnitude of an earthquake is given by this formula. Okay, that's how it's calculated. So we're taking his intensity compared to the reference intensity of like nothing happening, the zero intensity. Okay. So if we took earthquake 1 and we're comparing it to earthquake 2, and I want to see how much more intense one is the other, well, we're going to subtract our magnitudes to see the difference in magnitude. And that's going to be equal to this. And how do they get this? Well, let's look at this formula. What log law do we have for division? When they're divided inside, what can we do with them? Somebody said it. Okay, no, I thought I heard something, but I must be hearing voices. Which log law can I use to expand this guy right here? Well, yeah, the quotient. So it'd be log of I1 minus log of IO. Okay, minus. So that's what they did here. Do you see how they did that for us already? And this guy, we're going to use quotient. I2 minus IO. So what are we going to do with this negative here? We got to do what with it? Distribute it. So it becomes a minus log of I2 plus log of our reference intensity. So what happens here? What happens? No. What happens in his? Is there anything that cancels? Yeah, these guys cancel, which give us the log of intensity 1 minus the log of intensity 2, or intensity 1 divided by intensity 2. Okay, so that's how that formula was developed. So here's that formula. Okay, so if we're comparing how much more times intense one thing is to the other, this is it. Okay, they're going to give you at least one formula on there if you're given an application question on your diploma. So let's try another problem. How many times can you try this on your own? How many times more intense was Chile's 9.5 earthquake compared to the 2005 Chile earthquake, which was 7.8? Answer to the nearest whole number. So we want to see how many times more intense. So if we're looking for, remember this is our intensity, how many times more intense 1 is compared to 2, that's what that means. So what are we going to do here? 10 to the power of what minus what? What did you subtract? The first magnitude minus the second magnitude. If I want to compare the first to the second, it's first minus the second, which gives us 10 to the power of 1.7, so approximately the nearest whole number, 50 times more intense. Okay, let's look at a different type of question they can ask. A major earthquake of 7.5 is 375 times more intense than a minor earthquake. Is the magnitude of the minor earthquake greater or smaller than 7.5? Will it be greater or will it be smaller if it's not as intense? Brad? It will be smaller. Yeah. Okay, so this time we want to actually find the magnitude. They give us how many times more intense. So what is I1 over I2? What is that equal to? 375. So it's 375. The first is more, that many times bigger than the second. Equals 10 to the power of 7.5 minus x. So we're trying to find that second earthquake, right? If we were trying to find the first one, the x would be here, and this would probably be a smaller number. All right, how do we solve for an exponent? We can't make the same base. Logarithms, Kate. So what do we do to both sides? Take the log of both sides. Okay, so log 375 equals log 10 to the 7.5 minus x. Now what? Drop the exponent. Does anyone remember what log 10 equals to? The base is 10 as well. And type that into your calculator. Base and the answer are the same. It's always 1, right? Remember, this guy is always 1. If you can't see the base, it's a 10. So this is actually log 375 equals 7.5 minus x. What's our next step? Minus the 7.5. Could you type that into your calculator now? Yeah? So let's grab that calculator of ours. So we have, oh, this is from yesterday when, I don't know if it's on right now. There was, it looked like somebody was holding it. Yeah, anyways. Doesn't make sense anymore based on my, it looked funny with my backdrop before, but anyways. Whoa. Someone just fell down something. Okay, negative 4.93 equals negative x. So what's x equal to? The nearest tenth, 4.9. So the magnitude would be 4.9. Yeah. You could figure it out. Okay, so then we looked at, there's 3 different applications we're going to look at. The next is a decibel scale. And it's very similar to the earthquake, right? And it follows that logarithmic scale as well. So the current unit used is a decibel. If you work with music, you understand decibels, right? So it's equal to 1/10 of a bell. The bell scale, like the Richter scale, is a logarithmic. A difference of 1 bell, or 10 decibels, corresponds to a factor of 10 difference in sound intensity. So a leaf rustling, which is 10 decibels, is 10 times as intense as the threshold of hearing. What's the threshold of hearing? The point at which we can hear something. Very, very, very faintly. If you've anyone here had a hearing test before? I have. And it's like they see how low, because I have sometimes get really bad ear infections and stuff. So they have to watch it. But anyways, they see how low they can go until your threshold, so you can actually hear something. See how quiet you can go. So whisper, 30 decibels, would be 10 to the 3, or 1,000 times as intense as the threshold of hearing, or 100 times intense as a rustling leaf. Most likely you're just working with decibels. Yeah. So if you're looking at a power saw and you're looking at a telephone, okay, we want to figure out how many times more intense it is. How would we find that out? Well, it helps if you figure out how many bells it is. So how many bells is 120 decibels? 12 bells. It's 1/10. I'll use big B. Yeah, bells. How many bells is 80 decibels? 8. Okay, so how would we get how many times more intense it is? Minus 10 to the 12 minus 8 is equal to 10 to the 4, or 10,000. 4 zeros. So if you're comparing a jet engine to the threshold of pain, ow. Okay, how many bells is 145 decibels? How do you get that? You just divide it by 10. 14.5 bells. And 125 would be 12.5 bells. Yeah, so you just move it one to the left. And so now we can compare them. So its intensity would be 14.5 minus the 12.5 raised to the power of 10, or 10 to the power of 2, which is 100. Okay, why don't you try the next one? So you should have had 10 to the negative 3, which is 1/1000. All right, because you're going 3 minus 6, which is 10 to the negative 3. All right. Okay, so let's look at an example on the next page. So what we just did was this, right? So there's two different formulas. One's with if they give you decibels, one if they give you bells already. Then we don't have to divide them by 10, right? If they're given the decibels, we have to divide the decibels by 10. So we've been working with this formula already. So let's try a couple more. How many times more intense is the sound of a piano than a whisper? So the intensity of a piano compared to the intensity of a whisper would then be equal to 10 to the power of what minus what? 6.7 bells minus, how many bells would this be? 2.2. So what does that equal in your calculator? Probably a pretty large number, right? 10 to the power of 4.5 or what? Brady, you want to type that in? Thanks. It's the nearest whole number. If you were to type this into your calculator right off the bat, what would you need here? Brackets. So I'm going to do this with you, Brady. Just to show, like, you have to put this in brackets. Pardon me? What? Oh, yeah, I'm the very new. Yeah, exactly. What did I type wrong? 2.2 it should have been. I just went straight to the answer there. There you go. So 31623 times more intense. It's pretty loud. But like if you compare a whisper, right, to a very loud piano, that is a lot louder. Okay, so here's the formula changed into a log formula for you. Show that the decibel level for the threshold of pain has a sound intensity of this. Okay, so what did they give us? The dB, the decibels. So we know the decibels, these are dBs, is 125 equals 10 log. So we're going to work with this equation. We want to get that somehow. Okay, so what's the first thing we could do? Divide by 10? Yeah, we can divide by 10. So that gives me what? 12.5 equals log I over IO. Okay? Now we want to get the inside by itself. And if we're ever solving for the inside of a log, what do we have to do to it? Solving for the inside of a log. I want the inside of a log. Does anyone know what you'd have to do? Nope, because that's if we are looking for the exponent. So if we are looking for the exponent, we take the log of both sides. So if you're looking for the exponent, you change it to a log form. If you're looking for the inside for a log, you have to go back to exponential form. Okay, so whenever you're looking for the inside of a log, change to exponential. Okay, what's the base of this guy? 10. So remember this back in the day, went 10 to the power of what? 12.5 equals our inside, which is I over IO. We're almost there because we want this. So we're looking for the I. I by itself. How do we get I by itself? Multiply by IO. There you go. Okay. So if you're looking for the inside of a log, you have to change it back to exponential form. All right, we're almost done. Let's look at pH. And I'm going to go pretty quick through this because we've seen pH a few times, right? Okay, so here's our pH scale. A Dutch chemist introduced the term pH representing the power of hydrogen. I didn't know actually that it stood for that. That makes sense. It's the power of hydrogen. That's cool. Yeah, but my minor's physics. So I'm not, I can do chemistry. I've done chemistry, but I didn't know that was power of hydrogen actually. To measure the extreme wide range of hydrogen ions, concentration in a substance. So here we go. Here's our pH. We've seen this before. So if something has a pH, we're always comparing it. Like if we use our reference here of 0, the most acidic thing in the world, right? So what? This is the most acidic, right? And then we use pH 4 for our most basic. For our most basic, right?
There's going to be more acidic things in the other end.
Okay, well maybe. Pretty close. Right, this is pretty close to one of the most. Because it will eat through almost anything. Okay, so let's try a couple examples. So if we want to compare our pH, we're doing the exact same thing as if we did our earthquakes or our decibel scales. It's a very similar relationship where for each time we get one more to the right, it's 10 times more acidic. If we go one more place to the left, actually, yeah, it'd be 10 times more basic. Okay, so complete the following using the approximate pH values given. Tomato juice. What's tomato juice? 4 compared to pure water of 7. So how many times more acidic would this one be? How would we find it in a pH? What's the difference here, though? Would it be -3? No. This time we have to go the water minus our pH. Okay, because we're comparing how much more acidic, we're going actually the opposite direction. So it's 1,000 or 10 to the 3 or 1,000 times more acidic. A 4 is 1,000 times more acidic than a 7. So they're pH scales are kind of backwards from a Richter scale or a decibel scale. Right? The smaller the number, the more intense it is. Whereas in a Richter scale, right, the larger the Richter measurement, the larger the intensity. So it's backwards in a pH. So eggs, which is 8, compared to water of 7. How many times more acidic is it? Be 10 to the -1. Yeah, so 7, 10 to the 7 minus 8, or 1/10 the times. Oh, is this basic? Sorry. Thank you. Or 10 times more basic, alkaline. Yeah. But how many times more acidic then would it be? 1/10. Depends which way we're going. Are we saying more basic or more acidic? So milk of magnesia is 1,000 times as blank. So alkaline or acidic. So we need to check. So what's the pH of milk? It's 10.5. And what's blood? 7.5. Okay. So is it more basic or more acidic? It's 10.5. Is it more basic or more acidic? Basic. Yeah. So our or the yeah, I got this stuff's fun, right? Alkaline. Or you could also write basic. That's fine. Because, right, the larger the number, the more basic it is. And we're talking about 1,000 times. Blank is 100 times as acidic as normal rain. So if normal rain, what's rain? Is 5. So what's going to be more acidic? A 3 or a 7? A 3, a pH of 3. So what has a pH of 3? Vinegar. Okay, so now we're saying basic. So eggs, which is a pH of 8, are 1 over 10,000 times more basic. So if it's not as, obviously it's not as basic as something else, we need to add 4 to this pH because there's 4 zeros here. So what that would be 12, which is washing soda. All right, you with us?
Yeah.
Yeah. Okay. Do you want to try the next one on your own then? Give all of number 8 a try. And if you're feeling lucky, go to 9 and 10. But try number 8. Remember, alkaline is basic. Okay. So if we want to find out how many more acidic something is, 1 compared to 2, that's when you're going to go the pH of 2 minus the pH of 1. If we want to find how much more basic something is, then the first minus the second. It's the opposite order. Okay, so seawater and pure water. And you can also use logic. Dean? Okay, we can also use logic. When you have an 8.4 pH compared to a 7, is it going to be more basic or less basic? More. So we expect a number larger than 1, not a fraction. And so we're going to go 8.4 minus 7 and raise to the power of 10, which is 25 times. Okay. Now, if you look at a seawater compared to a swimming pool, what's a swimming pool? 7.5? Yeah. Respectively. Pure water was 7, swimming pool 7.5, seawater 8.4.
How is a swimming pool less acidic than pure water?
It's more acidic. Right? Because oh no, it's less. This one's less.
Yeah.
Because it depends on the chemicals that are in there. I don't know. Okay, sorry. Okay. All right. So if we're trying to see how many times more basic, do we expect it to be more basic or less basic than a swimming pool in this question? More. And so we're going to go which minus which then? 8.4 minus the 7.5, right? You can logically work your way through it based knowing how a pH works, which gives us 10 to the power of 0.9, or should have had 8 times. Okay? And this last one we've worked a lot with, this last formula. And you've also worked with it probably in chemistry. Yep. It's not like it's totally new to you. Power of hydrogen. I love that. Yeah? Okay, so let's go through a given question. A patient given a urine sample which was found to have a pH of 5.7. What was the hydrogen ion concentration? Okay, so here's our formula. What do we know? pH is 5.7. Okay, so if we want to solve for a hydrogen concentration, what's the first thing that's wrong with this? Can't have anything in front of our log. So how do we get rid of it? Divide both sides by a negative. So just bring it to the other side. Okay, if you're looking for the inside of our log, what do we have to do? We're looking for the inside of a log. Change it to exponential form. What's the base here? 10 to the power of negative 5.7 equals our hydrogen iron concentration. So you should have 2.0 times 10 to the negative 6 when you type that in. Okay. It's only Tuesday. Last one, is this one easy to find out? Just put it into the formula. Just go straight to your calculator, right? Because they give us the hydrogen iron concentration this time. Okay, and I'll just give it to you. Comes to 3.5. Alrighty. How was that? It's okay. So it's gonna. I just figured you needed some more practice. So it's 1 to 13 in this assignment. Yeah, it's 1 to 13 because it had different assignments all throughout. Yeah, so all of it. And it's good practice for those application type questions, which you should expect on your diploma and your unit exam.
I just worked out on the
Yep, this